Hey there and welcome. Have you ever stared at a long list of math formulas and just felt completely overwhelmed? Yeah, me too. Well, today we're going to change all that. We are going to take that intimidating sheet of symbols and transform it into a powerful set of tools, your very own mathematical toolkit.
Okay, so let's really think about this for a second. When you look at a page crammed with equations, what do you actually see? Is it just a random list of stuff you have to memorize for a test? Or is it a secret toolkit where every single formula is perfectly designed for a very specific job? That right there, that's the big shift in perspective. These aren't just rules, they are powerful instruments for solving pretty much anything.
You know, every great toolkit needs a solid foundation. And in the world of math, that foundation is built with the language of algebra. So let's pop open the first compartment and check out the essential tools that live inside.
First up, we've got Euclid's division lemma. Now, I know that name sounds a little intense, but the idea behind it is something you already get. It's basically the rule of fair sharing. If A is the total number of cookies you've got, and B is the number of friends you're sharing with, then Q is how many cookies each person gets, and R is the remainder, the leftover cookies. It's that simple. It's the fundamental tool for understanding how all numbers divide.
Next in the kit is a really handy tool for verification. Think of it as a way to double-check your own work. After you've found the highest common factor and the lowest common multiple of two numbers, there's a simple rule to make sure you nailed it. The HCF times the LCM will always equal the product of the two numbers you started with. It's like a perfect little balancing act, a quick and elegant way to know you're right. Now check this out. We have a beautifully balanced pair of tools for quadratic polynomials. Instead of going through all the trouble of solving for the roots, alpha and beta, these formulas give you an amazing shortcut. Just by looking at the coefficients a, b, and c in your equation, you can instantly find out the sum of the roots and the product of the roots. It's like having a secret back door to see how the polynomial works without having to solve the whole thing.
And here is a perfect example of math as a diagnostic tool. When you're looking at a pair of linear equations, you don't actually need to draw a graph to figure out their story. By just comparing the ratios of their coefficients, you can instantly diagnose the situation. Are the lines going to cross just once? Are they parallel, never going to meet? Or are they actually the exact same line, sitting right on top of each other? This little three-step checkup gives you the answer in seconds.
Okay, this next tool, this one's a personal favorite. Meet the discriminant. I like to think of it as a mathematical crystal ball. Seriously. Before you even start to solve a quadratic equation, this simple little calculation tells you the future. It predicts exactly what kind of answer you're going to get. Will there be two different solutions, just one, or maybe none at all? The discriminant knows all. And once that crystal ball gives you its prediction, it's time to bring out the master key, the one, the only, the quadratic formula. This thing unlocks any quadratic equation. I don't care how complicated it looks. You just plug in the values for a, b, and that discriminant d you just found, and boom, it hands you the solution. It is the most powerful, most reliable tool in your whole algebra collection.
All right, we've got our algebra shelf all nice and organized. Now, let's add a totally new set of tools to our kit. These are the ones specifically designed for decoding patterns and, forecasting what's going to happen next.
So the main pattern we're going to be working with here is the arithmetic progression, or AP for short. And the concept is just beautifully simple. It's a list of numbers where you're always adding or subtracting the exact same amount to get from one number to the next. Just picture a staircase where every single step is the exact same height. That consistent step up, that's what we call the common difference.
And to work with these cool progressions, you get this slick two-piece toolkit. Over on the left, you've got the tool to find any specific number in the line. You want to know the 500th number in the sequence? You don't have to sit there and count all the way. You just use this formula. And on the right, that's your summation tool. It adds up all the numbers in the sequence for you. So incredibly efficient.
Okay, let's move out of the abstract world of algebra and patterns and step into the real physical world. It's time to stock our toolkit with instruments for actually measuring space. This is your geometry section, which we're going to turn into your very own mathematical GPS kit.
We have to start with the absolute cornerstone of all geometry, the Pythagoras theorem. This ancient, timeless relationship inside every single right-angled triangle is just fundamental. It's the tool that perfectly connects the links of all three sides, and it forms the very basis for how we measure and navigate pretty much everything.
So now, let's take that ancient cornerstone and build something really modern.
We're going to use the principles of Pythagoras to put together a mathematical GPS. By placing shapes and points onto a grid, what we call coordinate geometry, we can develop tools to measure and navigate on any 2D map with incredible precision. And here is our very first GPS tool. Now, look closely. Can you see it? The distance formula is just the Pythagoras theorem wearing a disguise. Just think of it as your digital measuring tape. If you know the coordinates of any 2 points on a map, this tool will calculate the exact straight line distance between them. How cool is that?
So you can measure the distance between 2 points, sure. But what if you need to find a specific spot along that line? Well, that's where this tool comes in. The section formula is your precision point plotter. It finds the exact coordinates of any point that divides a line in any given ratio. You want to find the point that's exactly halfway, or maybe 2/3 of the way down the line? This tool pinpoints it for you.
And for the final piece of our awesome GPS kit, we have this impressive-looking formula. It might look super complicated, but its job is simple and incredibly powerful. The key here is you don't even need to know the base or the height of a triangle. All you need are the XY coordinates of its 3 corners, and this tool calculates the exact area. It's the ultimate tool for measuring any space on a map.
So let's just step back for a minute and look at the amazing toolkit we've just put together. We've gone from just a list of formulas to a set of real, genuine capabilities. This isn't just about memorizing stuff for a class. This is about unlocking a brand new superpower for problem solving. I mean, just think about what you can do now. You've got the power to decode the basic rules of numbers, solve complex equations, and even diagnose solutions before you start. You can predict patterns, measure distances on a map, pinpoint locations with total precision, and calculate the area of any space you can define. You've built a truly versatile and powerful toolkit.
And you know, that brings us to the most important question of all. A toolkit, after all, is only as good as the problems you use it to solve. We've organized all the instruments, from the diagnostic tools of algebra to the digital measuring tape of geometry. So the only question left is, now that you have all the tools, what problem are you going to solve first?